Good morning, students. Today I will explain one of the important concepts from moment of inertia. And of course, in the last video, we discussed about many problems from moment of inertia. But the difference here is, in all the previous questions, if you see, like ring, disc, cylinder, and sphere, in all those cases, we always deal with uniform mass distribution. In all those questions, we deal with uniform mass distribution. But here, if mass distribution varies from one point to another point, if any body is having some variable mass, then we have to use either integration method or derivative methods to calculate such problems, to deal such problems. And such problems I will discuss today. And these are all the questions given in previous JEE mains examination only. And in all these questions, we follow the same method. Okay, see and try to understand all these model questions first. And let me go with the first question. What is that? The linear mass density of a thin rod AB of length L varies from A to B as lambda of x equal to lambda naught into 1 plus x by L, where x is the distance from A and m is the mass of the rod, then its moment of inertia about an axis passing through A and perpendicular to rod B. See here, in this particular question, they're asking about a rod whose density is not constant. Here density is varying. So I will just draw here a diagram for the given case only. For example, let me consider a rod of mass m is taken. The mass of rod here will be m and length of the rod is L. But according to the given question, density is not constant. That means from here to here, while you are going from one point to another point, density always varies. And they have taken the rod name is AB. And what is the question here? Then its moment of inertia about an axis passing through A and perpendicular to the rod. That means if I just consider an axis like this is the axis of rotation. About this particular axis, we have to calculate moment of inertia for the given rod. For example, if it is having some uniform mass only, that means mass distribution is always uniform. At every point, density remains same. In that particular case, what is the formula for moment of inertia about this axis? That is ml square by 3. We know that. About an axis passing through center and perpendicular to rod is ml square by 12. By applying parallel axis theorem, here you will get ml square by 3 only. So if it is having uniform mass distribution, easily you can write the formula. But if density varies as lambda naught into 1 plus x by L, now you have to calculate moment of inertia. Now, for any these type of questions, it may be given a ring or disc or a rod or any particular object. We have to follow the similar method. So the first question is very much important. Please listen carefully, because the same method we follow for all the remaining questions also. Okay. Now, see here, for this particular rod, I will consider to calculate the moment of inertia for variable mass distribution. To calculate, we have to first consider a small element of rod. For that small element of rod, first we have to calculate moment of inertia. Then by integrating the moment of inertia from first point to the last point, then you will get moment of inertia for the whole rod. And then we have to use integration method. So for example, if I consider a small element here, the length of the element is dx. Let me consider length of the small element is dx, and this element is at a distance x from our reference point. First of all, for any such cases, you have to consider here small element of the body whose length was taken dx and which is at a distance x from the reference point. Okay, now you first try to calculate moment of inertia of only this element. Later you can integrate that. Now the total mass is given m only, na? Now they ask us, and we have to calculate here what is the mass of the small element. Okay, see here, the mass of the small element I consider dm. And what is the general formula for linear mass density? Mass is distributed here only along the length we consider, because we have taken it as a linear object only. We didn't consider any width of the rod here. So, okay, what is the general formula for linear mass density? In general, density means mass by volume, but here linear density means mass by length. So you can write here lambda is nothing but dm by dx, mass by length element only. So what will be dm then? Dm is nothing but lambda into dx. Okay, but we have to calculate here moment of inertia, na? What is the general formula for moment of inertia here? In case of variable masses, moment of inertia equal to I equal to, it is integral x square dm. What is the general formula for moment of inertia? Mr square only, na? In place of m, here we have taken element mass only dm, and in case of distance we have taken x only. So it is x square dm. Now this is equal to integral x square. What we can write for dm? And here you can write dm can be taken as, listen carefully, the first model is very much important, since we have to follow the same method for all the remaining questions. Okay, so integral x square, what we write for dm? That is lambda into dx. And especially here for lambda, one formula was given, na? What is the formula given for lambda in the question? Lambda is equal to lambda naught into 1 plus x by L. So that here you can write integral x square into, in place of lambda you can write lambda naught into 1 plus x by L. And now you have to calculate integration from initial point to final point of rod. That means from point A to point B. From the reference line, at what, which is variable here, x only variable, na? So what is the x value at point A? We have taken the distance from point A only, na? So x value from point A is 0. What is the x value at point B? That is whole length of the rod only, na? So that it is L only. So we have to take an integration from 0 to L. You see here that integration is to be taken here from 0 to L. First, lambda naught you can take common here, and in integration you will have x square dx, and if you multiply x square with this, plus x cube by L dx. what is the integration for x square? Integration for x square will be x cube by 3 because it is integration for x power n dx is x power n plus 1 by n plus 1 plus for x cube it will be x power 4 by 4l. Limits are from 0 to L. Now you see that you can easily calculate the integration value. So by substituting upper limit, it will be L cube by 3 plus L power 4 by 4L. And by substituting lower limit, both will become 0 only, na? So that I am directly writing this. So this will be lambda naught into L and L will get cancelled here. L cube by 3 plus L cube by, of course L and L will get cancelled only, na? L cube by 4. This will be how much then? 1 by L cube is common here, 1 by 3 plus 1 by 4 will be 7 by 12 only, na? So this will be 7 lambda naught L cube by 12 is the answer. That is the answer for moment of inertia. But in the given options for the question, mostly they won't give in terms of lambda naught, and most of the times they may give in terms of mass. The lambda naught value you have to write in terms of mass only. This is actually the formula for moment of inertia only, but the same thing you have to write in terms of mass m given. Okay, now how can you calculate mass m here? Again you see the same derivation again. See here, we have just taken here a small element of mass dm and whose length is dx at a distance x only, and directly we have substituted in the formula of moment of inertia by using the integration method, that is integral x square dm. Integral x square, in place of dm we can write lambda dx, but how lambda varies was already given in the question only, na? That we substituted and we have just calculated through integration method, and by substituting upper limit and lower limit we just got 7 lambda naught L cube by 12. Now if you want to write the value of lambda naught in terms of total mass m only, okay, now so what is the formula for m? That is nothing but integral of dm only, na? At different values the mass will be different, so here also we have to use integration method. So integration method from 0 to, of course first you better we convert into other form. What we can write for dm? Already I have written there. Lambda can be taken as mass by length, dm by dx. So that it will be lambda dx. Lambda means already we have written. What is lambda? Lambda naught into 1 plus x by L into dx. And this will be integral. Of course, lambda naught is common here. And integral dx plus x dx by L. In the same way, if you take the integration again, that is lambda naught integral dx will be x only, integral x dx will be x square by 2. It is also from 0 to L. By substituting upper and lower limits, so of course lower limit is 0 only, na? Even you substitute 0, everything becomes 0. So only better you substitute the upper limit, that is L plus L square by 2L. Of course L and L will get cancelled here. This will be lambda naught into L plus L by 2, how much? 3L by 2. That is the formula for total mass only. Total mass here we got lambda naught into 3L by 2. Now what we can write for lambda naught here? Lambda naught equal to 2m by 3L. Let me consider this is the second equation. Why we calculated this factor? To substitute in the first equation only, na? To write the equation for moment of inertia in terms of mass, we have taken this. So see that what is the first equation we got here? 7 lambda naught L cube by 12. Moment of inertia formula is 7 lambda naught L cube by 12. But in terms of lambda naught, we have to substitute this one only, na? 7 by 12 L cube, okay. In terms of lambda naught, we have to write 2m by 3l. Then this will be L and L will get cancelled, and 2 6 it will be, and finally 7m L square by 18. The final moment of inertia formula will be 7 ml square by 18. Have you understood that? Here you see here, what about the shape of the body given? We have just drawn it, and it is given clearly that mass distribution varies. In such cases, always you have to consider a small element of the body. Then that small element of the body with thickness dx at a distance x from the reference line, then you have to take an integration for the moment of inertia of that small portion, and later on you will get the answer as here. Understand? Now I will go to the next model, next questions also, which are in the same model, but the body will change. Here I have taken rod only, na? In all the remaining questions, disc will be given. Earlier already I told you that these are all the questions given in previous examinations only. In last 5 to 6 years, JEE mains examinations only, this model is given. All these questions. Okay. Now, I will go through the next question. See here. All of you read the question and what type of body is given. You please see here. A thin circular plate of mass m and radius r has its density varying rho equal to rho naught r. Okay. And here circular plate means, what is circular plate? It is nothing but disc only. Circular plate is nothing but disc only. So if any particular disc is taken, I will draw here the diagram, and we can see how does the density vary here. So I consider here a small disc only. Okay. And here it is the complete disc plate only. But now a small element is to be taken to calculate the moment of inertia of variable density. Na? So if a rod is taken, a small element of length we can consider. But if a disc is taken, and here you have to consider small element is nothing but a ring element only. It is a ring element here. Okay. Now, here to here, the length of the thickness of the element will be dx, and from center to this element you can take the distance will be x only. As in the previous case, we have taken the length of the element is taken dx, and it is at the distance x from the center. Now the same method we have to follow. I will explain you how to solve that. Now first of all, we know that here this is area only, na? This is area only, na? So that the density is given, symbol is given rho, whatever it may be. What is the formula for? What is the formula for areal density? That is mass by area. So that you can write here dm by dA. dm by dA you can write. Then what is dm then? dm can be taken as rho into dA. That means with respect to A, you have to take an integration here. Now, For that small element, I will write here the formula for moment of inertia. What is the formula of general formula for moment of inertia in case of variable densities? That is integral x square dm, which is equal to integral x square, but dm can be taken as rho into dA. Na? That areal element, you have to convert it into length elements. So you can just write here integral x square into rho. Of course, it is rho naught, I think. I will see that. And area means only the area of this ring element you have to take. For any particular ring, not the area of inside part, only the area of this particular ring. Okay, all of you are able to listen? Okay. In any particular chapter, if such things are given, if small element is taken for ring in the shape of ring, then always you have to consider the area element will be length of the ring and thickness, that is 2 pi x into dx. Now what is finally here? This is the density only. Na? What is the formula for density given? Formula for density given as rho naught into r. You just substitute here integral x square rho naught. We have not taken here r, we have to consider here x only. Rho naught x 2 pi x dx. What is the formula then? Rho naught is of course constant and 2 pi is also constant, and the remaining one is x power 4, x square into x power 4 dx, and which is equal to, the integration for this one is equal to rho naught into 2 pi x power 5 by 5. The integration from the reference point was taken at center and the disk is till the surface, till the outside circumference. So the x can be taken from 0 to radius of the ring, radius of the disk, whatever it is taken. So then finally what is the formula? 2 pi rho naught, by substituting upper and lower limits here, r power 5 by 5. This is the formula you will get there. But again, as in the previous case, you have to write in terms of mass m only. Okay, so better now you calculate. Let me consider this is equation 1. And how to calculate mass? If you are able to calculate, you can try to calculate it by your own also. Okay, so total mass, if you want to calculate, that is integral dm only. Na? Integral, what we can write for dm? Rho into dA only. That is nothing but rho means it is given rho naught x, and dA area means 2 pi x dx. Then it will be how much? 2 pi rho naught x square dx is there inside the integration. What is integration for x square? That will be x cube by 3. By substituting the limits from 0 to r, you will get here that 2 pi rho naught r cube by 3. This is the formula for m. Now we can substitute equation for m, equation for 2 pi rho naught here. Then it will, you will get in terms of m only. What is the formula then? I equal to, in place of 2 pi rho naught, you can write 3m by r cube. And remaining is r power 5 by 5. So this will be finally 3m r square by 5. And finally moment of inertia is 3m r square by 5 only. But see the question again. Here you see the question again, that they're asking here moment of inertia about which axis you see here? About an axis perpendicular to the plate and passing through its edge. They're asking. They're not asking about an axis passing through center, about an axis passing through edge only. So now we calculated the whole thing only about an axis passing through center, because the reference point was taken at center. Now you have to apply a parallel axis theorem to calculate moment of inertia about an axis passing through edge only. So according to parallel axis theorem, what we write here? According to parallel axis theorem, you can write I equal to IC about center, moment of inertia about center, plus m into distance between the axis square, that is this one. So this will be 3 mr square by 5 plus mr square. Totally how much it will be? 8 mr square by 5. Now the answer for the given question is 8 mr square by 5. See here, in the previous question and this question also, same method we have used. What is that method? First of all, we have taken a small element of thickness dx in both the cases, and the distance from the reference point to this element will be x only, and then we calculated integral x square dm. We substituted the dm formula there and we derived it. We will get the answers in terms of some constants rho naught. Then finally, by calculating m value, mass value, you can substitute in the formula for moment of inertia. You will get the answer here for moment of inertia about the axis which we have taken as a reference. But here the question is asked about another axis, so that we applied parallel axis theorem. Okay, this is also one of the important model question. Now you see the another question given in the previous exam. See the question: a thin disk of mass m and radius r has mass per unit area sigma equal to k r square, where r is the distance from its center. Its moment of inertia about an axis going through its center of mass and perpendicular to its plane is. Here also disk is taken, so that same method we have to use. I will quickly explain this because the same model already I explained, so that first I don't take the diagram again and again. So I will go through the formula for moment of inertia. What is the formula for moment of inertia? Integral x square dm. That is integral x square into dm is nothing but rho into dA only. Na? It is the disk only, so that area you have to take. And this is nothing but integral x square, and density here it was taken kr square. In place of sigma they have taken kr square, and area element is 2 pi x dx. R also can be taken as x only here. Now this will be integral 2 pi k, all the constants I have written earlier. Then the remaining factor will be x power 5 dx, and the integration value will be 2 pi k x power 6 by 6. By substituting the limits from 0 to r, how much it will be? Of course, 2 3s it will be pi k x power 6 by 3. That is the formula I got for moment of inertia. But you have to write in terms of total mass also most of the times. So Now you can calculate dm value. Let me consider this is equation 1. What is mass value integral dm? Integral rho dA. That is integral. What is the density given? Of course, kx square into 2 pi x dx is the value for dA. This will be 2 pi k x cube by x cube. X cube dx. You have to take an integration for this. This will be 2 pi k x power 4 by 4. I hope all of you understand. The previous two model questions were same, so that I am explaining very quickly this one. Okay. So by applying the limits from 0 to r, and you will get here the answer, that is 2 pi k r power 4 by 4. Now you can substitute this equation in the first equation. Then you will get, what is the first equation you got? Pi k x power 6 by 3. Of course, r power 6 you can write. Okay. Now you substitute in place of pi k, you can write, of course, here 2 by 2 it will be. In place of pi k, you can write 2m by r power 4. Here you have to write 2m by r power 4. That will be finally 2m r square by 3. And finally answer will be 2m r square by 3. And two more questions are also there given in the same model. Okay, I will give you the questions there in your description only. You please try to follow them and try to answer them. Otherwise, I will explain you in the class only. Okay, thank you.